Mixtures, particles in a solution are very tiny. They're too tiny to actually be seen. The substances that dissolves a solute to form a solution is called a solvent. The solute is the substance that dissolves in the solvent. One thing I mentioned before was when we put salt into water. Okay. So we put salt into water, and what's going to happen is the salt actually dissolves in the water. So the salt is known as the solute, and the water is known as the solvent. So whatever does the dissolving is the solvent. Whatever gets dissolved is known as the solute. And when we put them together, we form something called a solution. So mixtures. A mixture is a combination of pure substances. Each substance remains in its original pure form, although each is not always easy to distinctly mix, pretty much to see in the mixture that once it's been made. Okay? So we can mix two things together. We can mix the salt, we can mix the water. Both are pure substances that we've mixed, and we've changed now the composition of our matter. So we've put one type of matter into another type of matter, allowed it to dissolve, and eventually we form our own distinct mixture. Okay, there are four types of mixtures that we're going to discuss. One of them is a mechanical mixture. The other next two are going to be solutions and a suspension, and finally colloids. So let's look at the mechanical mixture. Mechanical mixture, okay, the different substances that make up a mixture are visible. I mix two things together, I can see them distinctively. They do not dissolve in the other. These are considered mechanical mixtures. Soil, an example of mechanical mixture. Okay, because I could see all the different components that make up that bit of soil. Another thing would be if I was to try to dissolve sand into water. Sand will not dissolve in water. I will be able to see the sand collecting at the bottom of my beaker. A mixture in which the different parts are visible is called a heterogeneous mixture. So here's another key term you're going to need to know. Heterogeneous. Different. Okay, throughout. Heterogeneous. So anytime you can see both things that you're trying to mix in together, we can see the sand, we can see the water. Okay, this is considered heterogeneous because we see both things. They've not dissolved together. Because if we dissolve salt now, okay, salt, into a beaker of water, we will not be able to see the salt. Okay? But if we were to do the same thing, but instead of salt, we're going to put in sand, then we can actually see the sand pretty much make its way towards the bottom. A suspension. A suspension is a cloudy mixture in which tiny particles of one substance are held within another. Tomato juice, an example of a suspension. Another one, milk and magnesia. Okay, it's not soluble in water, therefore it needs to be shaken. So if you had something like this to coat the inside of your stomach for an upset stomach, you have to shake, right? So pay attention to anything that requires you to shake the actual substance before ingesting it or eating it or drinking it. Okay. Particles of a suspension can be separated out when the mixture is poured through filter paper. A suspension is also considered heterogeneous because if you let it sit for a while, you will be able to see the two distinct layers separating from one another. That's why we need to shake them to keep them together, to keep the particles suspended within the entire container. So milk straight from the cow are natural suspensions. It quickly separates into two layers. Homogenization uses high-speed agitation to break the particles of fat into tiny droplets called emulsification. So what we're doing is we're taking globs of fat and we're breaking it down into smaller parts to let water molecules give the impression that it's dissolving it, but it's not. So these tiny droplets are so tiny that they remain suspended without really settling to the bottom. Okay? If the suspended particles are small enough, gravity will not cause them to separate. Okay? So if they're so tiny, they will not separate. This mechanical mixture is called a colloid. Okay? So it's a special type of mixture. Examples of such mixtures: jelly made of liquid and a solid combined together. Whipped cream made of a gas and a liquid. Other examples of colloids: your mayonnaise, paint, glues, butter, milk. All right, we talk about things like paint. Right, we want to shake it ahead of time, and when you're ready to paint, after you've gotten your can shaken to its max, the particles will not settle to the bottom. They will remain in that so-called colloid state. So, a few examples here of colloids. Okay, and notice here the different states in which matter is solid, dissolved, or mixed in with a liquid. Liquid within another liquid. Gases in liquids. Okay, so these are all examples of colloids that we see pretty much all around us. Okay, although colloids are heterogeneous, okay, mechanical mixtures, they appear homogeneous. They're consistently throughout, right? That can of paint, if it's a blue paint, it's blue at the top, in the middle, at the bottom. It's throughout the same. Homogeneous, the same throughout. Okay? The particles in a colloid are too small to be seen using an optical microscope, but they are larger than the particles in that solution. Okay? So a beam of light scatters when shined through a colloid, but it passes through solution. So if we had a solution, and we're going to talk about solution in just a second, okay? Because solutions are also considered homogeneous. They're the same throughout. If I was to mix, one of the examples I've used already in class, I'm going to talk about it in a second from now, is solutions. And when we mix salt into water, it's considered a solution. So we pass light through it. The light shines through it, okay? But you pass light through something that is considered a colloid, okay? The light will scatter in different directions, and that scattering of the light is called the Tyndall effect. So, finally, solution. As we said, salt dissolves in water. Here, the last example that I've got displayed. Okay? A solution, the different substances that make it up are not individually visible. I cannot see it. So I can have a beaker of water. Okay, I'll have my beaker of water. I'll have my beaker of salt water. You cannot tell by looking at it which one has the salt. So you take a sip from it, right? That's how you can tell. So if I took a sip from the top, the middle, the bottom, it's the same throughout. But of course, if that's just water, big deal. But if this was salt dissolved in water, I did the same demonstration where I took a sip from the top, I took a sip from the middle, I took a sip from the bottom. It will be exactly the same throughout. So the consistency, it's salt water at the top, salt water in the middle, it's salty water at the bottom. That is a solution. If I cannot see it, okay, that's one of the ways to be able to help me be able to tell. I cannot see the salt in the water. That's what makes it the solution. Because the salt has dissolved and we cannot really see it when it's been dissolved.